So we are talking about changing climate by human activities. But we haven't said how much it changes. So we must know something about our climate's sensitivity to perturbations. And it is measured in terms of the change in temperature we get by a doubling of the carbon dioxide. Carbon dioxide equivalent is done when you want to include other greenhouse gases and other effects on radiative forcing. Okay, when we say forcing, it is anything that changes the balance of incoming solar and outgoing long wave so that the energy that is available for changing the climate is known. Okay, that's the radiative forcing, or just called forcing. What is climate sensitivity? It is defined this way. Then I'll go back to the previous slide. You have, let's say, temperature at 0, some global mean baseline is set. Then you start increasing carbon at different rates. Here is carbon doubling happening in about 70 years, and the other one is happening much slower. So you can see that as CO2 is this is CO2 quadrupling here. Okay, so CO2 doubling happens, and then you fix the carbon. You don't emit anymore. Because carbon accumulates, so it has long residence time of a couple of hundred centuries, which means the carbon dioxide that is emitted from the beginning of the Industrial Revolution is still around. So you keep accumulating CO2. So even though you doubled it and stopped emitting more, the carbon dioxide in the atmosphere can increase. So you get what is called a transient response. So the climate is responding already as the CO2 is changing, and the warming continues. Remember, we saw this plots I will show again of the Antarctic ice core data of CO2 and methane increasing since Industrial Revolution, but temperature still lagging behind. That is kind of what is happening here. So the transient response is here, and then we hold the CO2 to that level for a long time, for several centuries, and the warming will continue to increase. Okay, so this equilibrium temperature you get on the long term to doubled CO2 is called climate sensitivity. You can do the same with quadrupling of the CO2. So when we do future projections, we basically need to know how our climate system responds to these changes in CO2 that we are causing. Okay, so estimates are made from the models and from previous changes in climate, like the Little Ice Age or the Younger Dryas and so on. So you know the radiation change associated with those, you know the temperature changes associated with those, and then you can do a range of climate sensitivities. So here are the ranges. Most likely is right here in the center. Very likely is in this the gray bar, and then the likely scenario goes out quite far. Okay, so the instrumental period has climate sensitivity of the order of 2 to 6 degrees or so, with likelihood extending all the way here in extreme cases. Okay, the current mean climate is somewhere here. Climate models are somewhere here. So climate models are not perfect, as we will see later on. Over the last millennium, the estimates are quite wide. What does this mean? Basically, things like volcanic eruptions, the sensitivity during last glacial maximum from data and from models and so on tell you that climate sensitivity is not a constant parameter. It's not always the same. It depends on so many factors. So as we keep tinkering with the climate, this sensitivity will not remain constant. In fact, just this year, some 40 scientists together put down the best estimate of the current time of our climate sensitivity. We need to know this because as we perturb the climate, we need to know if there is a possibility of a sudden jump to a new state from which we cannot go back, some kind of a irreversible change. For example, if all of Greenland glacier collapses, then even if you stop emitting carbon and so on, it'll be forever to build back the Greenland glacier, right? So you can have, and the sea level associated with that is going to be some 60 meters or so. So all these things are very important. Okay, so out of that we can revisit the data we saw from Antarctica, Vostok ice core. We've already talked about this sawtooth pattern, and we mentioned several times that here orbital forcing was causing change in temperature, and then methane and CO2 were following, whereas now we are increasing methane and CO2. Again, methane is in parts per billion and CO2 is in parts per million by volume. And the temperature is not increased yet. Why? Because the system has inertia and the energy goes into the ocean in melting the glaciers and so on. But as we saw here, the warming will continue. So even if we stopped the carbon emission right now, what we have emitted till now will continue to accumulate and continue the warming. That's what committed warming means. By the fact that we have emitted so much carbon since industrial revolution has committed us to certain amount of warming. That doesn't mean that additional carbon can be emitted without any consequence. Additional carbon will just cause more additional warming. So we need to prevent emissions anyways, but we have already committed to some warming by this. So here is the 2CO2 warming. If you have doubling of atmospheric CO2, direct radiation effect of the greenhouse gases is about 1.2 degrees C as estimated by current sensitivities. Clouds remain a dark horse. We don't know whether they will cause a net cooling or a net warming when they are changing in response to increased temperatures, increased humidity, and so on. Snow melting will add some albedo effect and increased warming. Positive feedback from the water vapor will add as much warming as the direct radiation effect. So altogether, the total warming we will get because of doubling CO2 is 3 degrees centigrade. Okay, now the models are getting better. They're including vegetation feedbacks and coral feedbacks and all sorts of detailed feedbacks in the Earth system, and they're saying that maybe the sensitivity is higher than this. Okay, so we must know the climate sensitivity, and also the previous climates like the Cretaceous 100 million years ago, which was one of the strongest global, the highest global mean temperatures in recent periods at more than 20 degrees, had the sensitivity somewhere here, and the ice house of the past had sensitivity or global mean temperatures somewhere here. Sorry, the atmospheric concentrations of ppm were very low or very high. In the Cretaceous, they were more than 1,000 ppm, as we mentioned before. So depending on the sensitivity, you could have ended up here or there. So the range of model projections for these kind of range of CO2s in the future hover around this range, going from 1.5 degrees to 4.5 degrees and larger here. So doubling of the CO2 from pre-industrial of 280 to 560 will give us, according to the model range, a warming of 1.5 degrees C to 4.5 degrees C. If we don't do anything. Of course, if we start drawing down carbon and start hiding it somewhere, we could change these, and we'll see that in fact that's the goal now, to keep the global warming to something like 2 degrees C or 1.5 degrees C. And by all arguments, we are already late for that, but we will see what we mean. So this is the point of climate sensitivity. I hope you got some sense that it is a measure of how strongly our climate will respond when we double the CO2 with respect to, let's say, the pre-industrial base period. I kind of ran through it, but the concept is simple, and yet it's not completely possible to constrain it completely. You look up the paper, I think it was led by Steve Sherwood, just came out this year in 2020, very good paper, but it shows you the complications involved, the difficulty of estimating climate sensitivity. But the concept is very important to make sure we know where we are going in the future.